Members, you are most welcome once again, and thank you for watching yesterday's lesson. I hope most of you enjoyed, and I got some concerns from Joel in Masaka. He was asking how best he can differentiate the quadrilaterals. So I thought of making this short video to explain something about quadrilaterals such that we can be able to know even their properties, because it's my duty when someone asks a question, I don't want to let it hang for long. Therefore, we want to understand what quadrilaterals are. Quadrilaterals are four-sided figures. Actually, any figure with four sides is a quadrilateral. And secondly, the word quadrilateral was derived from a Latin word, quadri meaning four, then latus meaning sides, meaning that when you put them together, it becomes four sides. So any figure with four sides is what we call a quadrilateral. I hope I'm answering you, Joel. Therefore, we have many quadrilaterals, but today we want to specifically look at two. However, we have quadrilaterals like the rectangle, the square, rhombus, parallelogram, trapezium. We have a kite as well. Now, today we want to specify looking at rectangle and a square. By the way, this question is commonly set. In most cases, children are asked to draw a square, but for them, they draw anything as long as it's a square. If the child is not taught the property, it is very hard to understand how best a figure can be drawn. I think you get me there. So the first quadrilateral we're going to look at is a rectangle. A rectangle has all its angles 90 degrees. All the angles of a rectangle are equals to 90 degrees, meaning that when you add all, you get 360 degrees, the interior angle sum of quadrilaterals, which is 360 degrees. And the opposite sides of a rectangle are equal. Now, let's look at this figure. For example, this is our rectangle. You can see that the opposite sides, this one and this down here, the length, this length is equals to the upper length. Then we have the width, which is this one, is equals to the other width. I hope you understand me. So when you get the difference here, you realize that a rectangle has two opposite sides equal and parallel. That means the length you are seeing here is equal to this length and they are parallel. Now the angle 90 we're talking about is this one. This is angle 90 degrees, this is 90 degrees, this is 90, and this is also 90. So when you add all, it gives you a sum of 360 degrees. So this is a rectangle. Its diagonals bisect each other. The diagonals bisect each other, mean that they divide each other. To bisect is to divide equally. They bisect each other. I hope we are together there. So this is a rectangle. We also have, when we meet next time, we shall talk about the other part of the rectangle, where we shall look at lines of folding symmetry. But today we want to look at some few property about each of them. So we have a square. This is a square. This is a square. A square, one of the strongest property here is that it has all sides equal. All these sides of a square are equal. And the diagonals bisect each other at angle 90 degrees. As you can see this symbol here, they bisect each other at angle 90 degrees. Now, when they tell this child in P3, P4, draw a shape of a square, please let this child be able to draw something like this. Most cases, children draw anything as long as it has a shape of a square. They don't even mind of the property, and it is marked wrongly or correctly. Now, when you look at this one here, Yes, somebody may say, the sides look the same, but what shows that it's a square? You can look at the difference between this work and this work. There's nothing which shows that they're the same. So when a child is taught to draw a square, please, this is how you can draw a square. I think we are clear there. Remember, this work is taught right from baby class. They tell them to talk about a square. But up primary 7, these children still can't tell us the difference between these quadrilaterals. So here is a brief lesson for us to differentiate. The next lesson will be about the remaining quadrilaterals. Now, a square is so unique that the angles that are in the center are also 90 degrees, meaning that the diagonals bisect each other at angle 90 degrees, or they are perpendicular to one another. The property of lines from symmetry, we shall look at it next time. But one thing that I want to urge everybody here, that parallelograms, we have a square. A square is also a parallelogram. A rectangle is also a parallelogram. So when we are to know that a square, a rectangle, and a rhombus, they are all parallelogram, from the word parallel, meaning that the lines, there are some pair of lines which are parallel. I hope you get me there. So those are also grouped under parallelogram. Though we are going to look at the property, the true properties of a parallelogram, then we shall be able to understand that, okay, it is true to group square, rectangle, and rhombus under parallelograms. I hope there we are very clear. So I'm giving you a very simple task. The next, before I come for the next lesson, do some research. Do some research about much more property on these quadrilaterals, such that we can have time to share all this. So the whole of this week, these days left, we are going to look at these quadrilaterals and explain it better for one another.